a quick little tutorial on how to use equation triangles and equation shapes. This is one of our formula sheets that you can purchase from our website at www.zenofchemistry.com. Essentially, just want to talk about how to use these equation shapes. The reason why I get students to utilize them, some people who take up chemistry are just not really mathematically minded. So this can help you to rearrange equations because it is a form of algebra, if you like. So it just gives you a simple way to rearrange equations without doing your head in. Some people don't like these very much from a traditionalist point of view, but my perspective is, well, if it gets the job done, who cares? So essentially, if we have a look at our equation shapes, most of them that you will use are the triangles, okay? And what a lot of students do is they actually get into the exam and the first thing they'll do is they'll write out their equation triangles, and there's a bunch of them. So they just get in there, and for the first 30 seconds of the exam, once they've got their pens, they just write them all down and they know that they're set to go. Okay, but if you have a look at all three of these, you can see that the horizontal lines pertain to a divide, okay, and the vertical lines are all multiply signs. Okay, so if we have a look at our triangle, which is the one that you're most likely to use, if let's say we want to find number of moles, okay, so we write down number of moles, we cover up number of moles, and we always work from the top left to bottom right. So in this case, we're going to start with little m divided by mr, or you might want to write it m divided by mr. In this case, mr is molar mass, if you were unsure. Okay, again, if you want to from there calculate mass, you would write down little m, and then you'd cover up little m, start from top left to bottom right. There's no top and bottom, but we just start left to right, n times mr. Okay, if we want to use our PV equals nRT one, this is actually a trapezium. It's a little bit different. If we have a look over, so this is our unit 1 and 2 sheet. If we want to use this one, it's a little bit different. So you'll notice we have this one or this one. And in this case, what we have to be sure of is that if we're looking for, say, V, okay, V is on the top in our top trapezoid, and V is on the bottom on our bottom trapezoid. So we always with these types of shapes want to choose from the bottom. So we would then, if we want to find V, we would use this one because V is on the bottom. Okay, so it would be N times R times T divided by P. Okay, let's say we want to find temperature. Okay, because temperature is on the bottom of this trapezoid, we would use the top one. So T equals P times V divided by N times R. Okay, and the same goes for, we have down here for our, what do you call it? Dilution equation, C1V1 equals C2V2. Okay, I prefer I for initial and F for final. There's lots of different reasons for that, but we'll come back to another time. But again, let's say we want to find the final concentration CF. We would use the top rectangle because CF is on the bottom. So we cover that one up. Start our top left, CI times VI divided by VF. If we wanted to find VI is on the bottom on this one, so we'll use the bottom one. CF times VF divided by CI. Okay, So that's just a quick little demonstration of how these work. You'll probably find that there's many more triangles than other shapes, but I found this to be a really useful way of helping students out who just really struggle with the concept of rearranging formulas. It just makes it nice and easy, and you can get on with actually learning chemistry.